Hello students, today we'll discuss about adaptive control. The topic covers the computer integrated manufacturing 6th semester as well as 8th semester. Adaptive control system is a logical extension of the CNC mechanism. In CNC mechanism, the cutting speed and feed rates are prescribed by the part program. The determination of these operating parameters depend on the knowledge and experience of programmer regarding the workpiece, tool materials, coolant conditions, and other factors related to the operation. By contrast, in adaptive control machining, there is improvement in the production rate and reduction in the machining cost as a result of calculating and setting up optimal parameters during machining. Adaptive control machining originated out of research in early 1970s sponsored by US Air Force, and the initially adaptive control systems were based on analog devices representing the technology at that time. Today, adaptive control uses microprocessor-based control and is tightly integrated with an existing CNC systems. Definition of the adaptive control machining. For a machining operation, the term adaptive control denotes control systems that measure certain output variables and uses to control speed or feed rate. Some of the process variables that have been used in adaptive control machining system include spindle deflection or force torque, cutting temperature, and horsepower. Here is we can see a block diagram of the adaptive control system. In initial stage, adaptive control have constraints, strategy, performance index, and then connect to CNC systems and that related drive commands and position feedback. And there is machine tool and the machining process and mounted on the sensors which is measure all constraints in adaptive control. The adaptive control is basically a feedback system that treats the CNC as in internal units and in which the machining variables automatically adapt themselves to actual conditions of the machining process. Performance index. It is usually an economic function such as maximum production rate or a minimum machining cost that is measuring parameters on adaptive control. Functions of adaptive control. There are three functions of adaptive controls are identification function, decision function, and modification function. The main idea of the adaptive control is the improvement of the cutting process by automatic online determination of speed and or a cutting. The adaptive control is basically a feedback system in which cutting speed and feed automatically adapt themselves to actual condition of the process and are varied accordingly to the changes in the work condition as progresses in adaptive control. Identification function. In this identification function, this is involved determining the current performance of the process or a system in science. The identification function is concerned with determining the current value of this performance measures by making use of the feedback data from the process in adaptive control. Second, a decision function. Decision function have the once the system performance is determined, the next function is to decide how to control mechanisms should be adjusted to improve process performance. The decision procedure is carried out by means of a programmed logic provided by the designer. And the third one, modification function. That the third adaptive control function is to implement the decision. While the decision function is logic function, modification is concerned with the physical or mechanical changes in the system. The modification involves changing the system parameters or variables so as to drive the process towards a measure optimal state. Where to use adaptive control? The adaptive control is not suitable for every machining situation. In general, the following characteristics can be used to identify situations where adaptive control can be beneficially applied. The in-process time consumes a significant portion of the machining cycle time. There is a significant source of variability in the job for which adaptive control can compensate. The cost of operating the machine tool is high. The typical jobs involve steel, titanium, and high-strength alloys can use the adaptive control system. Basic classification of the adaptive control system in NC. In the practice, the adaptive control system machine tools can be classified in two types. The basically adaptive control with optimization or adaptive control with constraints ACC and ACO. And geometric adaptive control GSC. Adaptive control with constraints are systems in which machining conditions such as spindle speed or feed rate are maximized within the prescribed limits of machines and tool constraints such as maximum torque, force, or horsepower. In adaptive control system, the correct feed and speed are automatically found and it is not necessary to spend effort on calculations of optimum feeds and speeds. Adaptive control with constraint system do not utilize a performance index and are based on maximizing a machining variable, that is feed rate, subject to process and machine constraints, that is allowable cutting force on the tool or maximum power of the machine, that is machine constraints here. The objective of the most adaptive control with constraints type of system is to increase the metal removal rate during rough cutting operations. The basic structure of the adaptive control with constraints here, and the adaptive control a routine and the required force and the spindle speed and the feed limits and the constants here, and the feed rate routine, the clock, and longitudinal z-axis control loop here, and the position and the velocity sensor, the lathe and the force sensors, and the feedback to the adaptive control in a input panel in ANSI system. Some examples of the adaptive control with constants here for to maximize the machining feed rate while maintaining a constant load on the cutter despite, despite variations in width and depth of cut. In a normal CNC system, the feed rate is programmed to accommodate the large width and depth in a particular cut, and this small feed rate is maintained along the entire cut. As a result, the machining rate is reduced. By contrast with the ACC system, the maximum allowable load on the cutter is programmed. As a result, when the width or depth of cut are small, the feed rate is high. When either the width or depth of cut are increased, the feed rate is automatically reduced and consequently the allowable load on the cutter is not exceeded. The result is the average feed with ACC is much larger than its programmed counterpart. Adaptive control with optimization. The adaptive control with optimized system for NC Machines tools is control system that optimize performance index subject to various constraints. It is basically a Sophisticated closed-loop control system which automatically works in optimized conditions even in the presence of workpiece and tool materials variations. That is basic structure of the SEO system here. We can see clearly on the all parts of SEO in the slide. Some drawbacks of the SEO here. The main problem is that this require online measurement of the toolware. So far there have been no industrial acceptable methods developed for the direct measurement of tool layers. Indirect measurement assumes that tool wear is proportional to other measurable variables such as cutting force and temperatures. The drawback of using this indirect measurement is to variations in their value can be caused by process variations other than tool wear such as workpiece hardness or cutting conditions. Geometric adaptive control. Geometric adaptive control are typically used in finished machining operations. In GSCs, the part quality is maintained in real time by compensating for the deflections and wear of cutting tools. The objective of the GSC is to achieve here is first one the required dimensional accuracy and a consistency of surface finish of the machine parts despite tool wear or tool deflection. That geometric adaptive control used for the finishing of the particular product only. Thank you.